Hey everyone, welcome to today's video, and this video is going to be about the rules of Boolean algebra along with the proof. And we are going to discuss these 12 rules of Boolean algebra, and in this video I'm going to discuss every single rule and we are going to see the proof of it as well. So as to how does these rules came into existence. So before that, let me request you to please subscribe to this YouTube channel and share this video with your friends if you really like it. Alright, so the first rule is that a dot 0 is equal to 0. Now let us see how this can be kind of proved using simple concepts of logic gate. Now this rule states that whenever a variable is kind of ANDed with 0, that is always equal to 0. So in other words, if at any instant of time one input to the AND gate is 0, the output is always 0 regardless of the value of the variable on the other input. So let us draw this using a logic gate. So let me draw one gate like this, and then the first input in this case would be a equal to 1, and in this case let us take one input as 0. So as you can see, when the output in this case would be 0. Similarly, if I draw this logic gate and take one of the inputs as 0 and the other input as 0 as well, in this case as well I'll get the answer as 0. So basically this rule is illustrated in these two examples where the lower input is always fixed at 0. So in the first case we have taken the input as 1, in that case the output is 0, and in the second case we have taken the input as 0, and even in that case the output is 0. Now the second rule says that the value of a dot 1 is equal to a. Now technically what this means is that whenever a variable is ANDed with 1, it is always equal to the variable. If a variable is 0, the output of the AND gate is 0. So let us say I draw a gate, and in this case if I take value of a as 1 and this as 1 as well, then the output in this case, x would be equal to 1. So similarly, if you take this AND gate and draw the two outputs in this case, which is x equal to 0, and if you take the first output as 0 and second as 1, even in this case the output would be kind of 0. So this is the second rule. Now let us go ahead with the third rule, which says that the value of a plus 0 is equal to a. So clearly in this case, since the plus sign is used, so this rule states that a variable, whenever it is ORed together with 0, it is always equal to the variable. So for example, if I draw an OR gate here, give it as two inputs, and let us take the first input as 1 and the second input as 0. So in this case the output will always be equal to 1. Even if I reverse the case and take an OR gate, give it two inputs, one of which is 0 and the other is fixed at 0. So 0 and 0 OR together, the output will always be equal to 0. The fourth rule of Boolean algebra says that the value of a plus 1 is always equal to 1. So technically what this is saying is that one of the input is fixed at 0. So for example, if I draw an OR gate, and if I fix one of the input as 1, the second input as in the first case taken as 0, so 0 and 1 OR together will produce the output as 1. And even in the second case, if I draw an OR gate here, fix one of the input as 1 and the second input as 1, the output in this case would be equal to 1. The fifth rule of this particular case is that the value of a plus a is always equal to a. Now how did this come into existence? Clearly you can see, since we are using a plus sign here, so that means technically we are using an OR gate. So let me draw an OR gate over here, and value of 1 is, one of the input is taken as 1 and the same value will go on the other input as well. So 1 and 1 ORed together, the output is always 1. Now even if I reverse the case and if I take both the inputs as 0, even in that case the final output would be 0. So that means whatever input we are taking here, we are getting that as the output. Then we have the sixth rule that says that a plus a bar is always equal to 1. So technically here what is happening here is that basically we are using an OR gate along with in the input in which the complement is also used. So let us take an OR gate, and in this case what we are doing is we are taking a combination of 1 and 0. So in this case the output would be 1, and even if I take an OR gate like this one, take the input as 0 and 1, the output in this case would be 1. So even in this case, as you can see, whenever the complement pair is taken, the output is always coming as 1. Now the seventh rule says that the value of a dot a is always equal to 1. So clearly we have to use an AND gate here. So let me draw an AND gate. And if I take the inputs in this case as 1 and 1, the output of this AND gate will always be equal to 1. Even in the reverse case, when I take this AND gate and give it the input as 0 and 0, the output of this AND gate is always equal to 0. So as you can see, whatever input you have taken, you're getting that as the kind of the output here. Now the next is rule number 8. So in rule number 8, what is going to happen is the rule says that a dot a bar is always equal to 0. Now how does that come into kind of existence? So that will come into existence when you take the AND gate and supply it with 1 and 0 on the one end and x equal to 0 on the second end over here. So now let us take this as 0 and 1, and x is equal to 0. So this is 0 and 1. So technically what is happening is we are using two inputs as a combination of 1 and 0. Now let us take rule number 9. So there are 4 more rules left. Let's quickly finish it off. So now we have the rule number 9. So rule number 9 says that the value of a double bar is always equal to a. So this is rule number 9. So what is happening here is that this rule states that a double complement of the variable is always equal to the variable if we start with the variable complement or invert it once. So for example, let us take an variable a equals to 0 and supply this to an inverter gate. So clearly this now will convert it to a is equal to 1, that is a bar is equal to 1, and if I again supply this as an input to the other inverter gate, now this will complement the output, so we will get 0. So as you can see, we have received the input that we had given. Now rule number 10 says that the value of a plus ab is equal to a. So for what we are going to use is the distributive law. So in order to prove this, let us take the LHS. So the value of LHS is a plus ab. That is, if I take a as common, so this is 1 plus b, and if I apply the rule of Boolean algebra here, that is 1 plus b, this comes out to be 1. So a dot 1 as per the rules is a. And then we have rule number 11. So rule number 11 says that the value of a plus a bar b is equal to a plus b. So we'll have to solve this. So a plus a bar b is equal to a plus ab plus a bar b. So what we have done is we have used rule number 10 that says that a plus ab can be taken as a. So in place of a, we have taken this as a plus ab. Now let us multiply this. So this is a multiplied by a plus a multiplied by b plus a bar b, and this is the rule that says that a dot a is always equal to a. Now let us multiply this. So this becomes a plus a bar multiplied by a plus b using the factorization of the distributive law. Now a plus a bar is always 1, so the 1 multiplied by a plus b, and 1 multiplied by a plus b finally is a plus b. So that means we have successfully proved that the value of a plus a bar b is equal to a plus b. Now let us quickly start with the last rule of Boolean algebra, that is rule number 12, that says that the value of a plus b multiplied by a plus c can be written as a plus bc. Now let us solve this using the left hand side. So this now is a multiplied by a plus a multiplied by c plus a multiplied by b plus b multiplied by c. Now let's multiply this. So this becomes a plus ac plus AB plus BC. So this now becomes A taken as common, this is 1 plus C plus AB plus BC. Now this becomes A dot 1 plus AB plus BC. Now if we take A from A taken out as common from this particular step, this turns out to be A dot 1 plus BC, and A dot 1 is A. So finally we have A plus BC. So this is the last rule of Boolean algebra. So I hope that this video was informative enough, and for more such videos don't forget to subscribe to our YouTube channel. Thank you so much for watching.